Welcome to the third video of Module 1. Today we're going to talk about dividing powers with the same base. So the first video was about multiplying powers with the same base. Now what if we divided them instead? First example here gives us here's an example of what I'm talking about. We have two powers. One of them is 10 to the fourth, the other is 10 squared. They both have the same base of 10, and they're being divided. That's what allows us to use this rule that we're going to learn today. So expanded form. Well, first of all, I just want to remind everybody that when you divide, you can just write those two terms on the top and bottom of a fraction line. So if I rewrote this as 10 to the power of 4 over 10 to the power of 2, that's equivalent. This means the same thing. And that's going to make the next step a lot easier. So when we write this in expanded form, I'm going to write it as a fraction. The numerator was 10 to the power of 4, which in expanded form would be 10 times 10 times 10 times 10. And the denominator was 10 to the power of 2, which would just be 10 times 10. Now, if you notice here, we have some matches on the top and bottom, 10 over 10. We know that any number over itself equals 1. And 1, when it's multiplied by other numbers, doesn't change those numbers. So you can essentially cancel those out and ignore them. We can do it again here as well. Look, 10 over 10 equals 1. We don't need to write 1 times anything. So the only important information left is 10 times 10. And there's nothing in the denominator other than 1, because those 10s over 10s equals 1. So really what we have left is 10 squared over 1. And we never have to write 1 as a denominator, meaning our standard form would just be 10 squared. Let's do another one. We have r to the power of 7 divided by r to the power of 6. Again, remember, when instead of using this division sign, we're going to make a fraction line, and I'll say r to the power of 7 over r to the power of 6. And it's important when you do this that the first term always goes on the top, second term always goes on the bottom. If we write this out in expanded form, the numerator of r to the power of 7 will be r times r times r times r times r times r times r. Let's see, 1, 2, 3, 4, 5, 6, 7. Yeah. And on the bottom, we have r to the power of 6. So it'll just be 1 fewer than we had on the top. And there are 6 r's. Now, just like last time, anytime we have any number over itself, that just equals 1. So all of these essentially means 1 times 1 times 1 times 1 times 1, which all just equals 1. And once we're done making those matches, there's only 1 r left on the top, which means r over 1. And because we never have to write the denominator if it's 1, our standard form is just r. Technically to the power of 1, but we don't need to write the power of 1. Okay, third example. Actually, quick break to look at how cute this puppy is. This is Petey. He's keeping me company during quarantine. Okay, number 3. P to the power of 5 divided by p to the power of 8. I'll write that as a fraction. P to the power of 5 over p to the power of 8. If you can look ahead a few steps, you might realize that something's going to happen in this case that has not happened in our other two examples. We'll see how it plays out. When we write this in expanded form, our numerator will have 5 p's being multiplied together. 1, 2, 3, 4, 5. And our denominator will have 8 p's being multiplied together. 1, 2, 3, 4, 5, 6, 7, 8. Again, let's cancel out. Hey, rather than doing individual groups like that, how about I just take 5 p's on the top, 5 p's on the bottom, and realize that those are all going to cancel out. And we're left with variables in the denominator, but nothing in the numerator. I mean, not nothing. There's a numerator of 1. So that actually equals 1 over p to the power of 3. We're going to wait to write standard form for a second, just because once you know the rule, standard form is going to be a lot easier. And I'm just going to show you what that looks like here in a second. Actually, let's do that now. You might have noticed this pattern in our first two examples, but let's go back and see if you figured it out. Our exponents were 4 and 2, and we ended up with an exponent of 2. 4 minus 2 equals 2. In the second example, we had an exponent of 7 and an exponent of 6. And our ending exponent, although it's not written, it's technically 1. That's because 7 minus 6 equals 1. So when you divide powers with the same base, you can subtract their exponents. So for this one, we have a 5 and an 8. 5 minus 8 is negative 3. So according to our rule, our standard form should be p to the power of negative 3. If we look back to our form here that we got by doing expanded form, we have 1 over p to the power of 3. That's something that we're going to learn a little later on, but just trust me for now, those mean the same thing. The real standard form is p to the power of negative 3. So using that rule, let's do one where expanded form is way too long for anybody to want to do. 4 to the power of 30 divided by 4 to the power of 25? No, thank you. I know that I'm going to actually do 4 to the power of 30 minus 25, because when we divide powers with the same base, we subtract their exponents. 30 minus 25 is 5. So standard form would be 4 to the power of 5. If we want to look at this rule using variables, it would look like this. Dividing powers with the same base. Any number raised to some power divided by that same number raised to a power equals that base with the two powers being subtracted. So I'll use another example. Let's say 10 raised to the power of 15 divided by 10 to the power of 4. That would equal 10 to the power of 15 minus 4, which in standard form would be 10 to the power of 11. Hope that helps. Great job. Go practice on MathSpace.